All right, it's 9 o'clock, so I'll go ahead and introduce us. Thank you everyone for coming to the first of the April series of the AG2PI workshops. So a big thank you to the FDA for funding this project and to our presenters, whom I will let them introduce themselves and the subjects that they will be addressing for the next 3 weeks. So go ahead.
Thank you, Holly, and thank you all for being here today. My name is Emmanuel Gonzalez. I am a third-year PhD student at the University of Arizona, and my research is right at the interface between plant science and data science. We are a team of a variety of graduate students and undergraduate students, so as we each come to present, the rest of the team members will will introduce themselves. So for today, we want to start off with an introduction to scientific computing. This is the first series out of 3 in which we will be giving you guys a general toolkit to leverage within your research. So I'd like to start off with a brief history into the internet. Now, when we take a look way back to Web 1.0, we were primarily consumers. This included websites such as Amazon.com, which started off as a bookstore, right? Users would go on there, buy their books, and just really consume data. With the evolution of the internet, we then arose to Web 2.0. And in this version of the internet, we were now creators. This included websites such as Facebook and other social media platforms. On these platforms, users could not only consume data, but they also generated it through postings of videos, pictures, things of that nature. Now, together with Web 2.0, we now have all of these different sensors that we use on a daily basis. This can include different types of smartwatches. It can include home speakers that allow you to ask specific questions to Alexa or your Google Home. And many of us depend on navigation tools to get around, even if we've been living in the city for many, many years. I'm on that boat there. And then we may also depend on Yelp, for example, for restaurant recommendations. So all of this is leading to a tremendous amount of data. So what we're looking at here is the progression or growth of data over the years, starting off with 2010, all the way to projections from 2025. Now, as a point of reference here, our y-axis is in zettabytes, and 1 zettabyte is equal to 1 trillion gigabytes. Now, if we take a look at 2010, there were about 2 zettabytes that were generated in that year. And moving on to 2025, projections are 181 zettabytes. So that's over a 170 zettabyte increase in a matter of just 15 years. Now, with that big data comes a lot of hype, right? And there's this idea of a hype cycle for both big data projects as well as big data in general. So oftentimes there's a technology trigger that leads to high expectations. And at this point, things are going really well. And then at some point, things start to go not so well. And there's this phase of disillusionment, right? So that's where we start kind of decreasing here, and we hit this trough of disillusionment. And eventually we hit a slope of enlightenment and eventually a plateau of productivity. So as you can see, right at this peak, traveling all the way to the plateau of productivity, that can take many years. Anywhere from 2 to 5 is usually the estimate. Now, why does that hype cycle occur? Well, it's because oftentimes there are many different ideas that are thrown around when a particular project arises. So for example, there are 2 sides to this spectrum. The first spectrum is at the very top, which it was this article that said the end of theory. The data, that data makes scientific method obsolete. Now, on the other side of this spectrum, there are others that were claiming you may not need big data after all, right? So there are these vastly different ideas that are thrown around right at the beginning of these technologies. Well, how do we actually leverage big data to be useful and scientific computing to actually extract information? Well, this is where we need to refer back to the data pyramid. Now, the data pyramid starts right at its base with raw data. This may be RNA-seq data that you're working on. It may be your phenomic data that you're working on, your livestock data that you're working on, whatever it may be. This would be your raw data right at the base. And then eventually we rise up the pyramid here and we go from data to information. This is where you start identifying differences in your treatments. You start identifying genotypic differences, for example, and eventually that information is what then becomes knowledge, right? You start trying to then understand what potential genes could be leading to this difference that I see within my data. And eventually we take that knowledge and apply it within our field and outside of our field to generate what's known as wisdom. Now, traveling from data all the way to wisdom is a time-consuming process. So let's take a look how we can apply the data pyramid within science. So here I have an example of plant phenomics. On the left-hand side of my screen, we can see the gantry, also known as the field scanalizer. This platform is a plant phenotyping platform that travels along these rails and takes pictures of plants. The system is 27 million grams or 30 tons in weight. And it generates an equally large volume of data. Now, taking a look at the right-hand side of my screen, we can see a much smaller phenotyping platform, which would be a DJI Mavic Mini drone. This clocks in right around 250 grams. So you can see a vast difference between the two in terms of weight. And although a drone cannot generate all of the data that the field scanalizer generates, it still produces useful information. And it's important to note that both of these systems are collecting data. And in combination or collectively, they generate many, many different types of data and many, many different types of volumes of data as well. Now, how do we take that information and then extract that knowledge? Well, here I have an example of the project that the team here works on. We start off with these three-dimensional point clouds, which are a three-dimensional reconstruction of plants. Now, within our raw data, there's nothing that tells us any phenotypic information about that plant. These data have to go through a series of pre-processing, post-processing steps in order to actually extract information and eventually knowledge. So we start off with the raw data, and then we focus in on one individual plant, for example. Once we have an individual plant, we may then be interested in segmenting this point cloud into different organs, right? We may say, okay, this is one plant, this is one leaf, and this is a slightly different leaf. And that then allows us to extract information at a different scale. So for example, now we're taking a look at leaf length, leaf width, leaf angle as an example. And eventually we combine all this information together to then understand how these plants are responding to drought conditions. Now, you can apply this to any of your projects and you can begin to understand how you would go through the data pyramid. So for the purposes of our workshop today, we're going to be really giving you guys a general understanding of what the data lifecycle is and how managing your data is really part of that data lifecycle. So we start off here with a plan. You might say, okay, I'm working with bacteria and I want to collect data on their growth. And you may then go and collect that data, whether it be image data or other. And then you have to process that data. If they're images, they have to go through a series of processing steps. Eventually, you collect some numerical data that you can then analyze and plot. You want to preserve or store your data, share that data with collaborators, and then eventually you may be interested in reusing your data. And this is very common with big data. Oftentimes, the methods that you use will change or evolve as your project continues, and it will be necessary to store that data somewhere that makes it easily accessible to then reuse it. So in this workshop series, we will focus in on processing and analyzing data. And as I mentioned at the beginning, we really want to build your computational toolkit. So in order to focus in on those two topics that I mentioned, we're going to kick off with session 1, which is the one that we'll be going over today. In this session, we will review Python and Jupyter notebooks. Now, if you're not comfortable with Python or Jupyter notebooks, if you've never seen this before, it is totally okay. This is the exact workshop for you. So we're going to start off very generally reviewing Python, and then we're going to build up into session number 2, which will be a week from today. During session number 2, we will review shell scripts, data analysis, and machine learning. Again, if you've never dealt with any of these topics, we will be covering them in a lot of detail to make sure that we're all on the same page. And lastly, 2 weeks from today, we will be hosting session number 3. Session number 3 will be focused on version control using GitHub. Now, we're going to be using a variety of different tools. Today, we're going to be using Jupyter Notebooks through Google Collaboratory. This is a service that allows you to run Jupyter Notebooks on the web. So this makes it easy for us all to be able to run the same notebook and have the same computing environment. Okay, so I hope that you guys are able to join us for these 3 different sessions. Again, these will be hosted 1 week after another. And with that, I will hand it over to our first presenter, who is Chosen.
Thank you so much, Johanna. Okay. Hello, everyone. So my name is Chosen. I'm a first year PhD student in the School of Plant Sciences here at the University of Arizona, and I'm part of Eric Leon's lab. My session this morning is I'm going to quickly introduce us to the concept of programming, and then quickly also talk about some of the basics in Python programming. Just like we're all aware, in order to execute a task, you have to give an instruction. And that's what programming is simply all about. It's simply a way of giving instructions to computers and telling them, this is what I want you to do, this is what I want you to do. And in order to do this, we have to give an instruction. And this instruction, it's usually in a special language that is called programming language. And in this training and workshop, we'll be focusing on Python programming language, but then there are several other programming languages such as Perl, C++, Java, and all of that. And if you are a newbie, starting off in programming, and you probably at the crossroad of asking which programming languages should I learn and all of that, one clue that I'd like to give you today is to start off by asking the question, what do you want to do with this programming language? In terms of this workshop, we're looking at scientific computing, and Python, it's heavily used in scientific computing. Assuming that we wanted to introduce it to the concept of designing websites and all of that, then we'll be talking about JavaScript and not Python, even though Python is also used in designing websites. So this is one thing to keep in mind as you progress in your career and learning programming. Now, Python, it's an object-oriented programming that was established and designed in 1991. And there are several reasons why it's actually widely used in science. One of these is that the codes in Python are readable, and they have simple syntax. And as we continue in my session this morning, you're going to see it, that the codes in Python are very human-friendly. Another reason is that they're also scalable. And then also the last reason why most people use it, in my opinion, is that it has a very large support community. So for example, if you're having issues with your code and all of that, there's like different communities that you can find to help you, which you can also easily find on the web. Now, one thing that I'd like to quickly talk about. Yeah.
Do you mind trying to make the font a little bit larger? If you could think you'd be able to zoom in on your browser or
Absolutely. Is this better?
yeah, if you want to try one more, yeah, let's go with that.
Oh, great. Okay.
And then just a quick announcement, the link to the notebook here that Chosen is sharing is in the chat. So go ahead and click that link in the chat so that we can all follow along as Chosen proceeds.
Yeah. Thank you. I'd like to continue by just quickly talking to us about interpreted and compiled programming language. This is basically the two broad types of programming languages that we have. Why do we talk about this, or why do we talk about compiling in programming? The reason is that when you write your code, for example, in Python, the codes have to be compiled to a language that the computer understands in order to be able to execute the instruction you're giving to the computer. And interpreted programming languages, for example, Python, have to first of all be interpreted before being compiled. Why compiled programming languages such as C++ are usually easily compiled and then read by the computer. And this is one of the factors that determines how fast a programming language is. And in order to help you understand this concept of interpreted and compiled programming language, I want you to imagine that you're a tourist and you find yourself, for example, in Greece. And then let's assume you don't understand Greek, and then you have a map that is written in Greek, and you're trying to find the direction to somewhere, and then you meet, maybe someone who is in Greece, and you're like, oh, can you help me interpret this? And then the person also doesn't understand English, and then looks at it, and it's Greek. In order for this person to interpret the map to you, the person would need somebody who understands English, who would be more like a middle person. So this is what it is. So the person interprets in Greek to the person who understands English, and the person who understands English then interprets it to you. So this is one good way, but assuming you understood Greek, then the person interprets the map to you directly. So this is how programming happens and how we're able to give instruction to computers. Now, moving ahead, I would like to quickly talk about notebooks. And like my colleague Emmanuel already talked about, we're using notebooks for this session of our workshop. And notebooks are very great for people who are just starting off in programming. And the reason for this is that notebooks present a form of interactive computing. It allows you to write your code, execute your codes, and also visualize the results. Notebooks are example of integrated development environments, and you need these IDEs in order to develop your codes. There are several other IDEs out there, such as VS Code, Sublime Text, and all of that. And in the next week workshop, you'll be introduced to other IDs. But in this session of the workshop, we'll be using notebooks. And like Emmanuel mentioned, we're using a notebook, the Jupyter notebook, but the Google Collaboratory notebook. And one of the major differences between the two is simply that the Google Colab is hosted on the web, while the Jupyter notebook runs on your local machine. And this is very convenient. Like, you would already observe from this workshop that just by sharing the link to our notebook with you, you're able to visualize what we're presenting, and you're also able to run your code. Assuming that we had a Jupyter notebook, we're not able to do this with Jupyter notebook. Another major difference between Jupyter notebook and Google Colab is that the Jupyter notebook, when it runs, makes use of your local machine hardware, such as your CPU, your RAM, and your hard disks, while the Google Colab makes use of all of those resources that are available on the Google servers. And also, if you're interested in machine learning, the Google Colab, to a great extent, it's a great platform for you to be able to try out your codes, because it gives you access to GPUs, and it also gives you access to TensorFlow processing units. And in order to do that, all you have to do is to come to the runtime, come to change runtime and be able to select the different hardware accelerator you may need. But I strongly recommend that when you don't need GPUs and CPUs, that you just go ahead with the default, which is now CPU. Quickly, now you might ask, how do you use the Google Colab? The Google Colab is very simple to use. And up here we have, if you can see my mouse, you have different menus that allows you to do different stuffs. But one important thing to keep in mind is that the Google Colab is made up of cells. And each of these are called cells, if you can see my mouse. And these cells can be either text, codes, images, or it can even be linked to YouTube videos, and among different stuffs. And at the top right, left-hand side, rather, you can be able to see the table of contents for this notebook that we're presenting. And then you can close that as well. If you want to create a new cell, for example, you want to create a new cell that you want it to be a code, then you use this button up here. And if you want it to be a text, you use this button up here. And I want you to go ahead and try this quickly just to be sure that you can do this. So I want you to create two new cells, one for a code and then the other for a text. And then another thing to keep in mind if you've created it is that at this right-hand side, you'll be able to use this button to move your cells up and down. You would also be able to include links, be able to delete it, and then also perform like other operations on your cell. I want you to go ahead and delete this because we don't need it. This is just for demonstration. So moving ahead, I would like to quickly talk to us about arithmetic operation in Pythons. Python basically follows the same arithmetic operation we have in mathematics, which is known as the BODMAS rule, if you remember that. But in order to perform different arithmetic operation, you will need different symbols. For example, if you want to perform multiplication, you need the asterisk symbol. And then if you want to perform like division, you need a forward slash. And then if you're looking at carrying out an exponential operation, then you need double asterisks. Moving down, we would like to just quickly perform a simple arithmetic operation. And here we have included different arithmetic operations just to demonstrate the example above. We have this command, which is print. And the print command simply allows you to output the operation you are carrying out in programming. So here we have print, and then we have a different operation in parentheses. And we're going to quickly run this cell. And to run it, there are different ways you can run your cell. You can simply click on this run button here, or you can hold your control and hit enter, or you can hold your shift and hit enter. So I want you to run this, and you might get this and just say run it. So this might take a few seconds, and you should have an output. And if you got the same output, can I see a thumbs up? Or if you're having any difficulties, you can also let us know. Great. So I think we can move ahead. So the next thing I would like to quickly talk to us about are variables, the concept of variables. So variables allows you to be able to store information when you're doing programming. And this is important because when you store information in variables, you can call this information or function or whatever it may be later on in your notebook or in any IDE you're using. So to just show you an example of the concept of variable, I have written a variable that is called seconds in a day. And then I'm using this equal sign to assign this operation to the variable. So we have the variables written in seconds in a day, equal sign saying whatever it's at the right-hand side, I want you to assign it to the variable. So when we run this code, what would happen is that Python is going to carry out this arithmetic operation and then assigns the output, which is the result of this operation, to the variable that is called seconds in a day. The same thing would also happen here. So here we have that we've created a variable called seconds in a day. And then I have the next thing, which is variable seconds in a week. And then I'm assigning it to an operation just by doing 7 times the seconds in a day in order to get the seconds we have in a week. And I want you to go ahead and run this. And you would not have any output. And this is because we've not used the print command. And whenever you create variable in a particular notebook, moving down in the same notebook, you can simply call that variable. And I want you to go ahead and run the next 2 cells. And when you run it, you get the output. So this just introduces the concept that after creating a variable, you can be able to call this variable as you move on. So moving on, I want to quickly talk about the data types, the common data types we have in Python. So in order to carry out operation in Python, remember I mentioned earlier that Python is an object-oriented program. So in order to carry out operations in Python, there are different data types that we have. The common ones are number, strings, and lists, and all of that, which my colleagues will be introducing you to later on. But one important thing to keep in mind is that Python treats numbers as, we have the rules, the same rules we have like in mathematics. We have, these are examples of integers, these are examples of decimal, and also concepts of strings. It simply allows you to create both text and numbers in Python. And in order to create a string, Python allows you to use a single quotation mark or a double quotation mark in order to create a string. Assuming you have a data type and you don't know whether it's a string or whether it's an integer or whether it's a decimal, you can use the command type, open parentheses and close parentheses, in order to determine what type of class of Python data it belongs to. And we can see an example in the next cell. I want you to run this. And if you run this, you see that the Python output tells you that, oh, the 20 that we've put in here and this command type, it's an integer. While the next one, which is 9.5, is a decimal, which is also known as a float. Moving on, I want us to try some examples on creating strings. So I want you to edit this cell. You can just move your cursor into the cell, and I want you to replace all of what I have in here with the name of your program. And then next, I want you to replace the next with the name of your college or your university. Okay, if you've done that, then I want you to just edit this next one and replace it with the name. So first of all, what we're doing is that we're creating 2 variables, and it's a string, and we're assigning this string to this variable, assigning also the string to this variable. And if you noticed, I've used a double quotation mark in the first line, and then used a single quotation mark in the second line. And then in the next line, I'm giving the command to the computer and saying, print whatever we've assigned to the variable program name. And then the next one was saying print whatever we assigned to the variable name of college. And I want you to go ahead and run this. And if you run this, you see the outputs of what we've assigned to our different variables. So this is how you can create the string. This is how you can also create a variable in programming. So moving ahead, I want us to quickly talk about string operations. So in string operations, you are able to carry out simple operations such as summing different strings. Here we have an example of we're creating a string A and B, and we're summing it. And at the same time, I am giving the command that says print. While in the next line, I've created a string and then also used my quotation mark to introduce space. And then in the last one, I've created also a string and then using also the quotation mark to create a space. And if you run this, you should get an output. First of all, the first one, the A and B is together. And this is because we didn't introduce any space between them. And then the next one, we have introduced the space using the single quotation mark. And then we have the last one that we introduced different space. I'd like to quickly conclude my session by talking to us about syntax errors. And this is because syntax errors is like one of the most common errors you get when you're doing programming. And what is a syntax error? A syntax error is simply an error you get when your code is not arranged in a particular format that the computer understands it. And to help you understand this, I want you to imagine that you want to tell a friend that, hey, I like data science. This is following a particular rule in English, but imagine that you tell that same friend, science, I data like. Even though you have the same words, the arrangement of those words matter. And the same thing is also applicable in programming. And we have an example here where we have this simple code, one line of code that says print, and then we have that the operation is outside the parentheses. When you run this, you're going to get an error, and the error is going to say, oh, it's a syntax error. But in the next line, I've corrected this, and we have that the operation is inside the parentheses. And when you run this, you should get the right output. So this is one example of common errors that you can get when you are programming in Python and other programming. But then there's also other errors that you can get. But as the workshop continues, we introduce you to these other types of errors. And yeah, and with that, I would like to hand over to Arian, who will be talking to you guys about Python packages. Arian.
Thank you so much, Chosen. So before I start, can everyone hear me okay and see my screen? Can you show it by a show of thumbs up? Just want to make sure that my voice is clear and you see my screen. Perfect. I see some thumbs up. Great. So
before you get started, I'm sorry. Can you also make your font bigger as well?
yeah, definitely. Thank you so much for mentioning that. Let me see. Is it okay now, or
let's go about double that if you don't mind? It'd be pretty
of course. How about now?
Maybe one more actually.
One more.
Yeah. So
better?
Yeah.
Of course. Okay. Let me find this. Perfect. So again, hi everyone. My name is Aryan. I'm a PhD candidate in the Department of Computer Science at the University of Arizona. I work on applications of computer vision and machine learning in different fields such as remote sensing and plant sciences. And with the Phi to Oracle team, I'm working on different projects from geo-correcting images, larger scale images, stitching point clouds together, working with 3D point clouds, and doing machine learning to extract useful information out of those interesting data. So during this workshop, just as a reminder, if you have any questions, if you're having trouble running these cells, we have some breakout rooms for you. You can join each of those breakout rooms. You can go to each of them with fewer people, and then there are people in those breakout rooms that they can help you. If you have any problems joining those breakout rooms, you can tell us in the chat and we can guide you. Okay, so thank you, Chosen, for introducing us to the basics of Python. In many of the programming languages, almost all of them, usually what happens is that they don't put all of the functionalities of that programming language in the core of the programming language. So usually when you install a programming language, the compiler for that, it comes with the basics, with the basic functionalities, basic packages, which are mostly used. And then if you want to use some advanced operations, or if you want to do some advanced thing, you have to install other packages. And the reason for doing that is to save space. So say you want to create a website using Python. As Chosen said, usually other languages are used, but Python can also be used for creating a website. When you want to create a website with Python, you don't want to install packages that are used for machine learning. So this way you can save space. So in this section, in this part of the series, I'm going to walk you through on how to install a new package in Python, on how to import that, how to use it. And in this section, we're going to discuss NumPy, we're going to talk about OpenCV, and also other packages like JSON. And after that, I'm going to hand it over to Travis. He's going to go over some other interesting packages for scientific computing. So let me begin by introducing NumPy. NumPy is a very widely used and famous package in Python, which is used for doing operations on matrices and arrays and tensors. And as you know, like array is a sequence of elements put together. Matrix is a two-dimensional sequence of elements. So we have rows and columns, and tensors are a more advanced sequence of elements with higher dimensions. So if you have a cube of numbers, like a stack of matrices put together, that's going to be a tensor, and anything with higher dimension, that's going to be a tensor. So NumPy, if you want to do any operation, any sort of operations like matrix multiplication, getting a transpose, doing any sort of operations like solving a system of equations, you want to use NumPy. There are other packages for that, like SciPy or other packages, but for the sake of this workshop, we're going to start with NumPy. So let me begin with showing you how to install this interesting package. So in order to install a package for Python, we use the pip command. And the pip command is a shell script command. We're going to talk about the shell script in the next session in detail, and we're going to show you how to use them. We're going to introduce you to the interesting shell script commands that we have. But for the sake of this first session, I'm going to just show you how to run this in order to install this package for you. Whenever you want to run a shell script in a Google Colab or Jupyter Notebook, since your code is technically the Colab and the Jupyter Notebook is ready to accept Python code, if you want to run a shell script, you have to use an exclamation mark at the beginning of your line. So here we are telling the Colab that you're going to run a shell script command, and the command is pip install NumPy. Since NumPy is one of those packages that are widely used, for Google Colab, it's already installed, but there's no downside if you run this cell again. Once again, if you have this error message, just run anyway. This is just a simple warning. So once we run that, it's going to tell us that you have already installed this package. So as you can see, there's nothing else that we need to do. Okay, so now this package is installed alongside of our Python interpreter. And the next thing that we need to do is to basically import that package into our code and then use that. The way to do that is by using this import command. And now, as you can see, we don't have any exclamation mark. It means that we are writing Python code. So here, I'm just importing the NumPy package, and I'm choosing an abbreviation for that just to for the convenience. So I'm just saying import NumPy and then change the name as an NP so that I can easily use that from now on. And the next line here basically uses this function within this package, which is called zeros. And this would create us an array with size 5 with all elements equal to 0. So if I run this cell, I'm going to have an array which is all zeros. And in the next cell, we're going to run this command to see what the array is. As you can see, the content of the arrays are 0, 0, 0. And the dot here, the period sign here is basically telling us that the data type for this array is float. So here we are dealing with floating numbers. In the following cells, I'm going to show you how to change that data type. So now let's move on and create a two-dimensional array, or what we call a matrix. In order to do that, again, we can use np.zeros, or we have another function which is called np.ones. It will create an n-dimensional array for us, which contains all ones. So here, by running this command, we're going to create a 4x6 matrix of all ones. So let's run this, and then in the next cell, we are visualizing that. And as you can see, we have a 4x6 matrix of all ones. In many cases, when you're working with these matrices, arrays, and tensors, you want to see their sizes, their dimensions. And in order to do that, we use the shape property of that variable. So here, if you go to the next cell, if I run this cell, it would print out the shape or the size of the first array, which is, we expect it to be one-dimensional, and the second one, which we expect to be two-dimensional. So if I run this, this is the result that I'm going to get. So the first one is a one-dimensional array of size 5. The second one is a two-dimensional matrix of size 4x6. So I'm going to pause here. Let me know if you have any questions. And by show of thumbs up, let me know if you were able to run all of these without any problems. Let me move on to the next part. Janet asked the question, are zeros and ones are defined with NumPy? Thank you, Travis, for responding. But yes, those are the functions that are defined within NumPy, so we don't have to worry about them. Okay, I saw some thumbs up, so I believe you all were able to run this. I'm going to move on to the next part. So here in this part, first I'm going to introduce you to the Python lists, and then I'm going to show you how to create NumPy arrays, how to initialize NumPy arrays from Python lists. So all of these things that we are talking about, Python list, dictionaries, NumPy arrays, they are all called data structures. There are different ways of storing data. So there are lots of more advanced structures like linked lists, trees, binary trees, which we're not going to into the details of those, because they're not used for this a specific task that we are trying to do, but just so that you know, we have other advanced data structures. But here, another interesting data structure is Python list. Before continuing, I see another question. What does zeros or ones mean here? I cannot understand the question. Yeah, thank you, Travis, for responding to that. I'm going to move on. So the Python list is basically a sequence of elements put together, and the order here is important. Those elements can be either numbers, floating numbers, integer numbers. They can be strings, or they can even be lists. So we can have nested lists. And the interesting thing about Python is that you can mix different types together into a list. So in other languages like C or like Visual Basic and other languages like them, you cannot mix different types into like an array. So if you have an array of strings, you should stick with that array or stick with that list. But in Python, you have the capability of having different strings and different types inside a Python list. The way to define it is by using brackets. So you first tell the Python package that you're using this as the name of the variable. And then after equal sign, you open up a bracket, you put the elements inside of that, and you close it up. So if I run this, I'm going to create 3 different lists. One of them is a number, the other one is the character, and the other one is a nested list. And in the next cell, if I run this, you're going to see that we have these 3 lines for these 3 lists that we created. And as you can see here, we can have nested lists, and inside one of them, we can have a mix of numbers and characters or strings. Now let's see how we can use Python lists to initialize a NumPy array. So oftentimes you want to create an array, say you want to create a specific array for a specific operation that you want to do. And the way to do that is, I mean, the simplest way to do that is to create a list or a nested list if you want to create a 2-dimensional or 3-dimensional array, and then convert it into NumPy array by using this function np.array. So this first, it would create us 2 different lists. One is the 1-dimensional, the other one is a 2-dimensional list. And then these 2 lines are going to convert those into NumPy arrays. There's one thing that we need to keep in mind at this point. In Python, it is possible for us to have nested lists with different sizes. So here, going back to this example, the first list here contains 3 elements, and the second list also contains 3 elements. But it is okay if I remove this element, and if I run this again, this will create us a unbalanced, if you want to say, nested list. And oftentimes in computer science, they call this a jagged matrix. It's okay to do that with Python lists, but if you want to create a matrix using NumPy, you have to make sure that the dimension of these inner lists are equal. So just keep that in mind. So let's run this cell and move on to this one, which is for the sake of visualization. So the first 2 lines is going to visualize the 2 arrays. The first one is a 1-dimensional, the second one is a 2-dimensional, and the other 2 lines are going to print out the shape of those 2 arrays. So as you can see, we have 3, 4, 5, 6 as the NumPy array here, and the other one is a 2-dimensional, and the sizes and the dimensions are as expected. So here we have 4 lists, each of them contain 2 elements, so we have a 4x2 matrix. Moving on to the next part, I'm going to show you how to save the NumPy list onto your disk. So many times when you're working with your data, whenever you're using any of these programming languages and you're running your program, in most cases, the data that you're working with is going to be saved on your random access memory or RAM. As you can see, we have our RAM here. It's showing up that we're using this much of our online RAM. And this random access memory is a temporary memory. Whenever you shut down your computer or the power goes off, you're gonna lose all of the data in your RAM. And in most cases, when you're done with your analysis of the data, or when you're halfway through, you want to save your work, usually you have to save that data onto your disk. And the way to do that is by creating a file. In NumPy, if you want to save an array, you have to create a file with the NPY format and then save the data onto that file. So here in the next cell, I'm going to show you how to use np.save, like here, to save that array here, the number array underscore 2d, into this file. And this file is going to be created in the current directory that you're working with. And the next line, I'm going to show you how to load that file. So basically, you just use the np.load function to load the contents of a file, of an npy file, into a NumPy array. So this would save this array into this file, and it would load the contents back into this new variable. So let's run this. We don't expect any outputs, but at this point, we expect that something is saved in our current directory. So let's use a shell script command, which is called ls. Again, don't forget about exclamation mark. And this would basically tell us what files there are in the current working directory of our system. So if I run this, you're going to see that I have this arr.npy file here. So everything is okay. So now if you move on to the next cell, and if you run this, we would see the contents of this loaded array, which we expect to be the same as this variable here, which is this matrix. So let's run this to see the contents and the shape. So as you can see, if I scroll up, you can see that the contents are the same, and also the shape is the same. So everything is okay with that. So before going on to the next part, I'm going to pause here to answer your questions if you have any, or to see if you guys were able to run this. So first, let me see if there are any unanswered questions in the chat. Okay, I see a question. Why are you using \n in the print? So \n in the strings is gonna basically, the thing that it's gonna do is to just create a new line for us. So let me move on to where I use this. Perfect, here. So if I don't use this, say I remove this, it's gonna print out the matrix in front of this string here. So let's run this cell one more time. As you can see, the first line of that matrix is printed out in front of that string, which is oftentimes we don't want to do that. We just want to send it to the next line. That's when we use \n. So this / is called escape character. So whenever you want to do some operation inside the strings, you use \. And there are other things that you can do. You can use \t. It's going to create a tab for you. So if I run this, you see that it creates a space here for us. And there are lots of other things like \r, which is going to print something out and then bring the cursor back to the first of the line so that you can print on the same line and things like that. That was a good question. Why do we use it? This is just for making it a little bit clean. That's the only reason that I'm using that. Exclamation mark. You're asking about exclamation mark, or? Yeah, ls. The ls is the way that the reason that I'm using ls is for basically printing out the name of the files that we have in the current directory. I just wanted to check if this file was successfully saved on my disk. And exclamation mark here again is used for running a shell script command, which is a Linux command inside a Python cell. So again, in Google Colab or Jupyter Notebook, we are technically running Python code, but if you want to run a shell script command, this is how you do that. Okay.
Yeah, and Arian, to show people that, we can also click on the little folder icon at the far left, and that will basically show them that those are the files that you were looking at when you ran the exclamation ls.
Exactly. Thank you so much, Emmanuel. That's a great thing. Yeah, here by clicking on this file, you can see all of the files in a much better format. So you can work with them. You can copy and paste and all of that stuff. Okay. If there are no more questions, I'm going to move on to the next part. So in the next part here, we are basically, I'm going to show you how to access different elements of these matrices and arrays. There are different ways of accessing elements. Here, I'm going to tell you the basics. If you have questions later on, we can talk, you can send us an email, but Python gives you a lot of power when it comes to accessing elements of matrices and tensors. So you can slice them, you can access a specific part or a specific range, all of that stuff. So first of all, for our reference, let us print the two arrays that we are going to work with. The first one is a one-dimensional array. Second one is a two-dimensional array or a matrix. This is just for our reference. And then moving on to the next cell, I'm going to show you the simplest way of accessing element of an array. The way to do that in most programming languages is by using brackets. So you have the name of your array, and then you open up a bracket without any spaces right in front of that. And then you specify a number. And that number is the index of the element that you're trying to extract or trying to visualize or get. So here we are getting the first element of this one-dimensional array, which we expect to be 3. So if I run this, this is going to be the result. If you're working with two-dimensional arrays, and if you want to still access one single element of that array, you have to technically specify two indexes. One, the index of the row, and the other one is the index of the column. And the way to do that is basically, again, using brackets and separating the two numbers with a comma. So here we are trying to access the element at row 1 and column 0. One thing to remember here, in many programming languages, the index starts at 0. I'm saying many because there are some programming languages like R, which many of you might have used that for your work. In that programming language, and I believe in MATLAB, the index starts at 1. So there are always these things that makes you confused, but make sure that you know in the programming language that you're working with, the index starts at 0 or 1. In Python, it starts at 0. So this tells us that we are looking for the element in second row, first column. So let's go back to this matrix. Second row, this is going to be this. First column is going to be 2. So if I run this, this would be the element that you're looking for. Perfect. There are times that you're looking for slicing a matrix or a tensor. Say you want to access a whole row of this matrix. The way to do that is simply by just, instead of providing two values and separating them by comma, you just provide one value. So this would give you the second row of that array, of that two-dimensional array. So let's run this. That would be the result, 2, 3. Moving on, there is also the option of selecting a range of rows or selecting a range of elements. The way to do that is by using the colon notation. So again, inside of the brackets, you can use the colon notation, and you can provide two. I mean, you technically should provide two values on the two sides of that colon that would specify the range. So here, since we are dealing with a two-dimensional array, we are providing a range for the rows. So you're saying that I want all of the rows from 0 to 2, but make sure that in Python, this second one is exclusive. So it's not going to give you the row at index 2. So it's going to give you the row at index 0 and the row at index 1. Again, since this is a two-dimensional and we are only specifying one range of values, it's going to take the whole row for us. So if I run this, the first two rows are going to be selected and printed out. So 2, 4, 3, 4, 2, 3. That's as expected. But if you want to select, say, the two rows and the first column, the way to do that is by mixing up these notation together. So after this 2, you can put a comma and then write 0. It means that I want the first two rows, but not the whole row. I just want the first elements. So if I run this, I'm going to get 3 and 2, which is going to be this and this. You can also, again, use a range for this part. I'm not going to run all of these cases. You can play with that at your own time. So let's move on to the next part. One of the other interesting things that Python has and many other programming languages they don't have is to use negative indexing. So negative indexing basically lets you choose elements at the end of this list. So oftentimes you are looking for the last element of the list. The way to do that is by just typing -1 as the index here. So again, we are working this time with the one-dimensional array. I'm accessing the last index. -1 is the last element. And if I run this, it's going to give me value 6 here. You can also do -2, -3, and all the way to the first index of your array. And you can mix this negative indexing with all of these other notations. If you use it for a two-dimensional, it's going to give you the last row. And the same concept works for other dimensions. So before moving on to the next part, which is running operations on these NumPy arrays, I'm going to stop here. First, by show of thumbs up, can you tell me if you were able to run the codes or not?
And Arian, Fred had his hand up, so I don't know. Fred, do you still have a question?
We have got it handled.
Okay, perfect.
Okay. Thank you, Emmanuel and Travis. I see a couple, more than a couple, thumbs up. So I'm confident that you were able to run that. Let me check for any questions. Is there any questions that Travis didn't answer? And by the way, thank you so much, Travis, for answering the questions. Okay, I see another question. Also, if you want to print the column as column and not as row, because you're going to... Okay, yeah, that's a good question. So if you want to change the, well, let me first bring that result back. So Piyush is asking a question. He's saying that if we run this cell using this notation, it's gonna give us 4 and 3 in a row format. You can change that into a column format by using a function that is called reshape. You can use that reshape. You can also use transpose, which I'm going to explain in the cells below. You can use all of those commands, but technically, for the sake of like using this result in your scientific computing, in most cases there is no difference between column and row vectors. But if you're interested in doing that, you should use np.reshape. Let me see if I remember the syntax correctly. So np.reshape, say we want to reshape this into a new shape, which is going to be, if you want it to be a column, it's going to be 2 by 1. So if I run this, that's going to be the result you're looking for. I hope that answered your question. Okay. If there are no more questions, let's move on to the next part. Okay, so here in this part, I'm going to show you how to do basic operations using these NumPy arrays and matrices. But first, let me show you how to create a random matrix of a specific size with a specific range of values. NumPy has a sub-module, if you want to call it. As if you hold your mouse over this module, you can see that np.random is a sub-module or a module under NumPy, which you can use to generate random numbers, random arrays, matrices, and all that stuff. And one of the interesting functions that it has is randint, which basically gets from you 2 numbers for the ranges of the random values and a size, and it would create a 4 for this case, it would create a 4 by 4 matrix for you with all the values between 0 and 10. So here, by running this cell, we're going to create 2 different matrices, A and B, which are randomly initialized, and we just randomly initialize it for the sake of running these operations. For our reference, I'm going to run this in order to visualize these 2 matrices, and as you can see, these are random matrices. Remember these values, if I rerun this cell and print that again, it's going to change the values, and that's what we expect. Perfect. Let's move on. The first operation that I'm going to explain is pairwise addition. Whenever we have same size matrices or arrays or tensors, we can add the corresponding element of those 2 matrices together by using this plus sign in Python. So if I run this, it's going to add the corresponding elements of these 2 matrices together, and it's going to put the result into this variable. And once we print it out, it's going to give us the result. So let's check one of the elements. I'm going to check the first element. So if I add 5 to 7, the result is going to be 12. So this is pairwise addition. We have the same or similar operation for pairwise division, multiplication, subtraction. So for the division, we use /. This would divide the elements with the corresponding elements from A and B. As you can see, this is the result. You may note that we have an infinity value here And can anyone explain what that is? If you know, you can unmute yourself or type it into the chat or however you like it. As a quick help, it goes back to the math. Exactly, Janet got it right. So if we divide it by 0, that's what we get. Since division by 0 is not defined, NumPy would basically give us this infinity value. Perfect. And also here we have that explanation. Okay, the next operation that I'm gonna explain is pairwise multiplication. So for the pairwise multiplication, it's very similar to the division. It just multiplies the corresponding elements. You can use an asterisk for this. And as you can see, this is the result. I'm not gonna check that. I'm very confident that NumPy and Python got it correct. Let's move on to the next operation, which is transpose. So if you're familiar with linear algebra, transpose is a very, very useful operation in matrix multiplication, matrix operations. And basically, when we are doing a transpose of a matrix, we are substituting the rows and columns together. So the first row becomes the first column, the second row becomes the second column, and the elements on the diagonal, they're not going to change. So this GIF is basically showing how this operation is performed. In order to do that in NumPy and Python, the only thing that we need to do is to use this .T property of a NumPy array, and it's going to give us the transpose. So let's run this. It's going to get a transpose, get the transpose of matrix A. So remember this set of values, 5, 9, 6, 8. This is the row. We expect it to be the first column of the original matrix, 5, 9, 6, 8. If you move here, you see that 5, 9, 6, 8 is the first column. So this is how you get a transpose. It's used in many, many different operations. So say you want to solve a least squares problem manually without using the packages, this is one of the operations that you definitely need to use that. So let's move on to the last operation, if I'm correct, which is matrix multiplication. This is another very important operation in linear algebra. In almost all of the applications of linear algebra, you're going to have matrix multiplication. So this image, first let's see what matrix multiplication is. Let's refresh our mind. If you want to multiply two different matrices together for any reason, there are lots of reasons and applications for that. But if you want to do that, the way to calculate a matrix multiplication is by multiplying the elements of the rows of the first matrix by the corresponding column of the second matrix. And in order to do the matrix multiplication, in order for the matrix multiplication to be applicable, we need to make sure that the number of rows of the number of columns of the first matrix is equal to the number of rows of the second matrix, because we need to multiply these elements by these elements. And if the numbers are not equal, we cannot perform the matrix multiplication. So here, the numbers are equal. We multiply the elements of the first row by the first column, and then we add them together. That's going to be the value of the first element in the resulting matrix. So this is how matrix multiplication is done. The way to perform this in NumPy is by using matmul. This is the function np.matmul, which is short form of matrix multiplication, and then providing two matrices with proper sizes. So if you do that, you're gonna get the result of the matrix multiplication. Let's run this. And I'm not gonna check that. It's a very lengthy operation if I want to do it by hand, but again, I'm pretty sure that the NumPy got it correct. Okay, so that concludes the NumPy section. If you're interested in learning more about NumPy, you can follow this link. It takes you to the documentation of NumPy. It's a very interesting package. If you have any questions at this point, just let me know. and we could just pause for a couple minutes, 1 minute before going to the next section. How do you? Okay, I see some questions. How we can inverse matrix? Well, if I'm not mistaken, I don't know if I remember this correct. Let's create a new cell. np dot linalg. Yeah, linalg is basically the linear algebra package, and there's this inverse function that basically we can use to inverse a matrix, and we should make sure that the matrix has an inverse or it's invertible. So if I run this, it's going to give me it's going to give us the inverse of that matrix, which is this weird guy here with all these floating values, but this is how it's done. That's a good question. How do you import a matrix from a file such as a CSV? Okay, that's a great question. If you want to import it from a CSV, Trav is going to talk about importing from CSV. We can use Pandas, or we can use the CSV package to import data. But in most cases, if you're working with these arrays and matrices, it's better to save it in the NPY format, which I explained here on the top in this cell. Yeah, cell number 13. So you can use this format to save and load the values. But if you want to use CSV, you have to wait until Travis tells you how to do that. But there is a package called CSV that you can search for. Perfect. I don't see any other questions. Is there any other questions before I move on? Because at this point, we're going to switch gears a little bit. Okay, let's move on to the next part. Excuse me. Okay, so in this part, we're going to talk about operations on images, videos, and all that stuff using OpenCV. OpenCV is another useful package. You might have heard of this package. It has a Python version, it has a C++ version. It's a very widely used package. You can do all different computer vision methods using OpenCV. In this part, we are going to show you how to first grab an image from web, how to visualize that image, how to work with that image, what is the concept of channels, how the images are saved on computer, how can we perform operations on the different channels of these images, and all that interesting things. So first of all, let me first show you how to import this OpenCV package. The way to do that, again, OpenCV is already installed. You don't have to install it. In order to import it, you just say import CV2. Does anyone has a question? Okay, this is the way to import that. Yeah, that's it. So first, let me show you how to find the random image from the web. There's this interesting website that's called Pixum. We can use that to find random images of a specific size. If I copy this and paste it into my browser, you can see that it's going to give me just a random picture of a specific size, 400 by 200. If I run this again, it's going to give me a different picture. It's good for like debugging your project, or if you're, for example, designing an application, you want to have some random image of a specific size. That's a good website for that. For here, we're trying to find a random image and do some basic operation on that. So I'm using this link to grab that random image from web. And in order to do that, here again, we are using another bash script command, which is called wget. It's used to download a web page or a file or a picture from web onto your local machine, onto your local disk. And here we are specifying a file name using this argument, and then using the other argument, we are specifying a link. So this would get us the picture. It's going to save it as img.png. Once we run this cell, it's going to first download this, and then it's going to run the rest of the commands, which are going to be Python commands. In order to read an image from disk, OpenCV has this imRead function, which basically gets a name of the file and also the path to that file from you. And it's going to read it into a NumPy matrix or tensor. And then since it's a NumPy tensor, we can use the shape to see the size of that image and the dimensions. And also in order to visualize it, OpenCV has a function called imshow. We can use that to visualize pictures. But in Google Colab, since we are using this web browser interface, we cannot use that because that's going to open up a new window for us, the default function of OpenCV. Instead, we are using this CV_imshow from Google Colab package in order to visualize that image alongside with the notebook and below this cell. So let's run this and see what happens. As you can see, it's trying to grab that using HTTP request. It downloads the image, img.png, it prints out the size. We have a 200 row, 400 column, and 3 channels. So now we are working with a 3-dimensional array or a tensor, and this is the image that we have. So before moving forward, I'm gonna explain how the images are stored. Many of you might have already know that, but the way that the images are stored in computer, if you're dealing with a grayscale image, it's basically a matrix, a 2-dimensional matrix of values for each of the pixels. Say we have a 50 by 50 image, we're going to have a 50 by 50 matrix of values between 0 and 255. And that 0 to 255 is the range that's mostly used if we are dealing with the 8-bit image. And that value basically represents the intensity of the pixel, of each of those pixels.
Mickey Mouse might say.
Can you please mute yourself? Thank you. If you're dealing with an RGB image, as you know, we can generate almost all of the colors that we can see using 3 main colors, which are going to be red, green, and blue. So if you're dealing with an RGB image or a color image, we're going to have to save 3 different values for the intensities of these 3 main colors. And by combining those 3 colors, we can visualize almost all of the colors that the human eye can see. And that's why we are having 3 different channels here. Those matrices are called channels. So it's like saving 3 different images for each of those bands or channels, 1 image for red, 1 image for green, and 1 image for blue. And then the computer, when it tries to visualize that, it's going to use those values to combine the colors together and create this beautiful image for us. So this is how the images are saved. And this is another explanation of how this matrix is saved in computer. We have rows, columns, and channels, 1 for blue, 1 for green, and 1 for red. As the value gets closer to 256 or 1 in this case, which is a normalized version, it gets brighter, and as it goes close to 0, it gets darker. So does anyone have any questions about how the images are stored before I move on? Okay, so let's move on. In this part, I'm going to show you how to use the things that we've learned so far with NumPy to slice the images and grab each of those channels and basically visualize them to see what they look like. So here, if you remember, we can use comma and colon notation in order to access different parts and ranges of a matrix or a tensor. And here, what we are trying to do here is to basically separate different channels and save them into different arrays and variables, and then visualize them. The way to do that is by using the colon and comma combination. So here, since we are not specifying any values on the 2 sides of the colon, we are saying that give us all of the rows, all of the columns, but only the channel at index 2. So what happens is basically it's going to ignore this, ignore the second one, and also grab this last channel. Note that in OpenCV, the channels are reversed. So the last channel is actually red and the first channel is blue. So this way we're separating these channels, is we are slicing them up, and then using the CVIM show, we're visualizing those 3 channels. So let's run this and see what we get. So as you can see here, we get 3 different images of like grayscale images, which we expect, because once we separate these channels, they become grayscale images. There's no concept of color into them. And that's what we get here. So the brighter the pixels are, means that the value of that color of that channel is higher. So here in the blue channel, these regions are dark. It means that we don't have a lot of blue. If we go back to the image, you see that these area is mostly green and yellow, which is a combination of green and red. So we don't have any blue here. So if I move down, you can see that the green channel and the red channel are bright in the bottom half of the picture, but not the blue channel. So you can see how these colors are put together to create that image. So now the thing is, in most cases, when you're working with images, you want to visualize each channel in its own color. So you want this grayscale image to be blue, so to kind of show you how dark the blue is or how light the blue is, like this picture we have here. In order to do that, we need to do a trick, basically. We need to, again, put the image back from grayscale to RGB, but this time, we don't want to have anything in the other 2 channels. We only want to have values for this channel, and we want empty elements in the other 2 channels. In order to do that, we need to use the merge function. We need to use the merge function from OpenCV, which is a function that basically merges the channels together. First, let's create an empty channel, which is going to be used for all of these functions. I call it 0, 2D. The way to do that is by just, as you remember, mp.zeros and providing the shape, which I'm using the shape of the red channel in order to keep it consistent. And then this function here that I'm using on top of the mp.zeros is basically converting the type of the mp.zeros into unsigned integer or unsigned 8-bit integer. And the reason for that is the pictures in OpenCV is saved using this format. That would take the values between 0 and 256. Okay, by running this, for the first line here, I'm adding 2 empty channels for the blue and green, but I'm using the red channel, and also the same goes for the green and the blue channel. And this way, I'm just modifying these channels. And when I'm visualizing it, as you expect, you can see these values. So this would show you how much blue, how much dark blue or light blue you have in different pixels, and also for the green and also for the red. So again, as we expect, since the sky is almost white or bright, we're going to have all of these colors, which this is what we have. And also, again, if you remember the bottom half, we don't have a lot of blue, but we have some green and some red. Okay, by show of thumbs up, can you, before just going to this part, can you show me if you were able to run all of the cells up until here? Perfect, I see some thumbs up, so I'm very confident that you guys were able to run that. I don't see any unanswered questions, so let's move on to the next part. So now let's do something, some applications. Let's see some application of this thing that we just learned. So in plant sciences, oftentimes if you have pictures of like aerial pictures of a field or of a region, or if you have UAV images and you want to measure how much vegetation you have, one of the things that they use is called a vegetation index. Vegetation index is basically an operation, a calculation that you run on the images that you have in order to highlight the regions that they have more vegetation, basically. One of the interesting and mostly used vegetation indices is called Triangular Vegetation Index, or TGI. It has a very basic formula. This is the formula here. You have some coefficient, you multiply those coefficient by the elements of different channels, and you add them up together, and that's going to give you a grayscale image that highlights the region with more vegetation. If you're interested in this, you can follow this link. It's going to give you more vegetation indices, which are more advanced. They might use other channels other than RGB. If you have near infrared bands, if you are infrared bands, you can extract information, useful information from those. And this is not only used in plant science and agriculture. In other fields, if you want to detect ice from satellite imagery, if you want to detect burned lands, you can use different indices that there are available out there. So you can play with those bands for yourself. Okay, so let's move on. Here, again, I'm going using that wget shell script command to download a picture, but this time I'm downloading a specific picture. So again, going back to that useful website, if you want to grab, if you find an interesting picture, if you want to download that specific picture, you have to provide an ID and then the sizes. So if I run this, let me grab that and run it in my browser. It's going to bring that picture for me. Every time you run that, it's going to be the same picture of the same cute dog. So let's move on. So by running this, it's going to download that picture into this file. And I'm reading the file. I'm using the notations that we learned to separate the channels. And then we are using the TGI format, the TGI formula to calculate the vegetation index. And then we are visualizing that vegetation index and the image together to see what parts of the picture has more vegetation. So let's scroll down. And as you can see, and as we expect, these greener areas, which we have more vegetation, are brighter in the TGI picture. But the dog, when the region around the dog, which doesn't contain any vegetation, it's darker. So this is an application of what we've just learned. You can use that for histology images. I'm pretty sure there are some indices for histology images to highlight some of the regions. Again, for satellite imagery, there are lots of indices, and you can play with that. Perfect. So let's move on to my last section, which is working with Python dictionary and JSON. But before that, is there any questions about image processing in the OpenCV package? Or by a show of thumbs up, again, I would really appreciate if you can show me if you're able to run all of these cells. Perfect, thank you so much. I see a lot of thumbs up. I'm going to pause for a couple seconds to see if you guys have any questions. Okay, it seems that we are okay. We can move on. So let's move on to the next part. So here, I'm going to introduce you to another interesting data structure, which is called dictionaries in Python. In other programming languages, you might have heard of map. That's another name for this. So dictionary is basically a list of key value pairs, which is used to accelerate accessing elements of a list. Say you want to have a phone book of the phone number of your friends. The easiest way to save that is by just basically having the name of your friends as key values and having their phone number as the value. And whenever you are trying to call your friend, you just search through the keys, find that, and then right in front of the key, you have the phone number, you just call that. And if you do that, you can, if you create a dictionary in computer, you can often index those key values, or I shouldn't say key value, you can index the keys and quickly access them. I'm not going to go into the details of indexing and binary search and all that stuff, but if you're interested, you can send me an email, we can chat later. but that's why dictionaries are used. Here, let's begin by showing you how to create a dictionary. But before that, I see some questions. I guess Travis is answering them. Pause me if you have any questions that I need to answer. Okay, so here first, I'm creating a dictionary by using curly brackets. The way to do that is to first defining a name, opening up a curly bracket, and then using the colon notation. I am saying that I want to use this as the key and this as the value. So the name of the person is going to be the key, and the phone number is going to be the value in this case. So if I run the cell, nothing specifically happens. It just prints out the dictionary, which is in the same way that we defined it. There is this function that's called keys. That's going to give us all of the keys that we have in the dictionary. So if I run this, it's going to tell me that we have person 1 and person 2. You can use this to go over your keys and do operations on that. The way that we access the elements is very similar to accessing the array elements or list elements. We just use normal brackets, and inside the normal bracket, instead of using indexes here, we use keys. So we just say, give me the phone number of person 2. If I run this, you're going to see that I have his phone number, which is going to be this. In order to add new elements to your dictionary, you can use very similar notation to accessing, but this time, if you're trying to give a key that's not in there, and right after that you have this equal sign and a new phone number, it's going to add that phone number to your dictionary. So let's add this phone number to the dictionary and then print it out. As you can see, it's going to add the third person, the phone number, and we're going to have a longer dictionary. So now let's use this dictionary and invert it to create a caller ID dictionary. So oftentimes when someone calls your phone, if you have their number saved into your phone, you can use the caller ID dictionary lookup to find the name of the person who's calling. So the way to do that is to basically replace or substitute the key and values in the phone book dictionary that we just defined. So here in this cell, I'm going to introduce you to 2 more syntaxes in Python, which is for loops and if condition statements. So basically, for loop is used for going over all of the elements of an array or a NumPy array or a list or dictionary keys. I'm not going to go into the details of how to use for loop. There are different ways of using that. There are other loops in Python and other programming languages like while loop or do, which I'm not going to go into the details. If you're interested, you can send me an email. We can chat about it later. But here, basically, this line tells us that I want the Python package to go over all of the keys. And the keys are basically, we define the keys here that it's going to be all of the keys in our name dictionary. And then for each of them, give me the key, and then I'm going to do an operation with that key. And the operations are happening here in an indented block of code right below the for loop. So here we are first trying to grab the phone number of that key, and here the key is actually the person, the name of the person. And we are grabbing the phone number, and then we are defining an empty dictionary for our caller ID, which is basically, at this point, we are substituting the phone number and the person name. So here, using this notation here, I am telling that the phone is going to be the key and the name is going to be the new value for this new dictionary. So if I run this, I'm going to initialize this lookup dictionary, and then in the following blocks of code, I'm going to run that. So let's, for the sake of our convenience, I'm going to separate these two, and I'm going to here print out the ID lookup dictionary to just see that. So here, as you can see, the keys are numbers again at this point, and the values are the person's name. So now let's access a phone number. So if say this phone number is calling us and we want to see the name of that person. If we need to check, first of all, we need to check if that number exists in our dictionary. If it doesn't exist, and if we try to access that, it's going to give us a runtime error, which you don't want that to happen. That's why we are using an if statement. An if statement is basically very similar to the if statements that we have in English. So we just say if something is in something else. So I'm saying if this number is in the ID lookup dictionary, then we're okay. I'm just accessing that and printing out something. Otherwise, using the else statement, I'm just saying that this is a new phone number. So let's run this. This is a new phone number. If I remove the 7 and substitute the 9, that's going to give us the first person's name. This is what we expect. So this is dictionaries in Python. In order to save dictionaries onto your disk and in order to save lists onto your disks, you're going to have to use JSON format. JSON is basically a mixed version of like any combination of lists and dictionaries, nested lists, nested dictionaries, all of that. You can save it as a JSON file. So here in this block of code, we first import JSON. Again, JSON is installed. We don't have to worry about it. And then I'm going to show you how to use JSON.dump and JSON.load to save and load dictionary values or list values into a file and vice versa. The way to do that is first open up a file. With this code, I'm just opening up a new file, and I'm going to open it into writing mode. So this W tells me that I'm going to open it up into the writing mode, and the file name is this. And then I'm using the dump function in order to dump the content of this dictionary into that file. And ls, if you remember, it's going to show me the files that we've created so far. And using a similar command, I'm going to open up a file into the read mode at this using this value. And then I'm going to load the contents of the file into a new dictionary, and then I'm going to print it out. So let's run this. As you can see, first, we're seeing the output of the ls, which is this one. As you can see, ID lookup file is saved. And then when we read the contents and printing out the contents, that's going to be our dictionary. So this is how you save the dictionary or lists onto your disk. So let me know if you have any questions, or by show of thumbs up for the last time. Let me know if you were able to run all of these cells. Perfect. I see a lot of thumbs up. That's great. So Travis, are there any questions from before?
Yes, so Travis has answered all of them. We just had a question pop up, Arian. So if you want to take a look.
Sure. How to build a dictionary if you have two lists, for example, a list of people and a list of their phone number? Okay, well, that's a good question. So it depends how you want to hold those two lists together. You can have a list of, or a nested list. Basically, you can, let me create a new cell for you here. So I'm going to call it temp lists. You can have it like this. Say the names are going to be my name and Travis. And then in a new list, you can have values like 1 and 2. This is one way to save that. You can save them into different files. You can save a dictionary instead of saving two lists. Does that answer your question? But in JSON format, you have to have one element in the root. So you cannot have two elements in the root. That's why you have to just put them into another format like this. I hope that answered your question.
Sorry, maybe I can just ask. I think I'm still a little bit confused. Could you say that again? So you were starting to put the names into one sort of sublist and then their numbers into another sublist?
Exactly. Yeah, the thing is, in JSON format, you cannot, the root element of the JSON format has to be one element. It has to be either one dictionary, one list, So you cannot technically have two lists into your JSON, into the JSON file. And
Okay.
because of that, we create this outer list here as our root list. And then inside that, we have two nested lists, one of them for the names and the other one for the numbers.
Okay.
Is that clear?
Yep. Yeah. Thank you.
Of course. Any other questions? Perfect. If there are no other questions, I'm gonna hand it over to Travis. And thank you guys.
Hey everyone, give me 1 second to get set up here. Emmanuel or Arian, one of the two, can you reach out to Bohulrem, Bholurem in the direct messages? He has a question about making masks in NumPy.
Sure.
All right, can y'all see that okay? Good deal. Okay, and can everyone hear me okay as well? Sweet. All right. So over the last little bit, thank you guys again for being here. My name is Travis Simmons. I'm an undergraduate biology major at the College of Coastal Georgia and a research data specialist at the Pauli Lab. Over the last little bit, again, thank you guys for being here. And you guys have been learning about doing all kind of data analysis and reading stuff in, basics of Python, all that good stuff. And so far, we've worked with basic data types like floats and integers, and we've also worked with NumPy arrays, and we've also worked with images. However, a lot of the times what I work with are CSVs, or those files that you always see in Excel that look something like this. I'm sure we've all seen these at some point in our scientific careers. You got rows, you got columns, and this is how we usually are collecting our data out in the field or in the lab, or however you want to do it, right? So usually you would save this in an Excel file when you're in the lab, right? But when you're programming, you don't really want to save it like that. You want to save it as a CSV. And so what a CSV is this exact same thing, except it's saved with just commas separating everything instead of rows and columns. So it's the same deal. And you can use Excel or any other program to save your data as a CSV instead of a XLSX file or whatever the format is for Excel. So we're going to talk about using this tabular data to do data analysis and visualization. And just like what Arian was talking about with all the other packages, NumPy, OpenCV, and all those good things, we have a package called Pandas that helps us work with tabular data, with CSVs. So here in this cell, which is just under the JSON, stuff, you will see a file path. This is just a file path to some of our experimental data that was collected using that big gantry that Emmanuel showed in the very beginning, that giant robot that scans stuff out in Maricopa, Arizona. So we can run that cell. And we're just saving a file path to that. Then we can do our import statement with Pandas, just like we did with NumPy. Then we can use the Pandas method readCV onto that file path to import our data. So this is going to read in this giant table of data that we have from one of our experiments. And it looks like it ran okay, so that's awesome. But let's check and be sure it read in correctly. And this table has over 100,000 rows. So we're not going to print all of those. We just want to look at the first few, right? And in order to get a little tiny view of what we just read in, we're going to use this method called head. So we read in that table and we stored it in a variable called df. And that's what we call tables in Pandas. It's called a data frame. So you have a frame of data with rows and columns. And so we can use that df.head to display the first 5 rows of our data frame. And as you can see, we have this giant table here with a bunch of different cool data that we collected. And by default, if we don't pass anything into this method, we're going to show the first 5 rows, but we can show more or less by changing the number in there. So if we want to do the first 12, we can see the first 12. If we wanted to do just the first one, we can see the first one. So let's talk about what we're looking at here. We're looking at some data that we collected in our field. We had a bunch of lettuce, and we identified them by using machine learning, and we measured them about how big they are in meters squared. So we have this column that's meters squared right here, and we measured them over a long period of time, and we each gave them a different treatment, which was a well-watered, a water-limited, and a control group. So right here we have treatment 3, which is our water-limited group. So lots of times you're not going to want to just comb through these giant tables of data that sometimes have millions and millions of rows. You're going to want to do some data exploration. And one way to do that really easily is to make some plots. And one thing that I found really cool when I was first learning to code was I always saw these really beautiful graphs in all these papers that I was reading. And I was always so mesmerized about how all these researchers were making these cool graphs. And they were doing it through code. And there's packages, just like we have Pandas, to make these graphs, one of which is Seaborn. So that we're gonna look into Seaborn right now. We have the documentation linked right here. So if we open up that documentation, we see some cool stuff. So Seaborn is another package that we use specifically for graphing. And we can go through and we can look at all these different graphs that Seaborn can make for you based off of data frames from Pandas. So you can take this, and if you want any kind of cool plots, it'll show you how to make these using Seaborn in these little cells. We are going to make a box plot, objectively the best plot, and we're going to go in here and try to figure out how to do that with our data. So here we can see the documentation for box plots, and so we're going to use this to make a box plot. And if we go into this cell, we're going to do our import statement for Seaborn, and then we're going to use the method boxplot. And we're going to compare the parameter bounding area meters squared, which remember is a single size of one of our lettuces that we identified in our field. And we're going to compare it to the categorical variable treatment. So this way we'll be looking for a mean parameter, differences in mean parameter response among our different treatments. So we can just run that, and Seaborn will automatically group all of our data and make it look all nice. And just like you would want to put this in a paper, you can change all these graphs, and there's a ton of arguments as to make them look any different way you want. But as you can see here, there wasn't a huge difference between our groups, which is okay, but we got a bar graph out of it. And in the same way, any type of tabular data that you have in a CSV format, you can read that in and make a bar graph or make any of those graphs that Seaborn has available. So I'm going to take a short second here to be sure that there are any questions in the chat or anything like that, Arian and Emmanuel.
Yeah, we have one question.
Yeah.
I don't know if you want to address it, Travis. So they're asking about how does this compare to ggplot2 in R?
Yeah, it's a very similar package. Seaborn is a little higher level, or a little lower level, excuse me. Anyway, it's a little simpler to use. It's more abstracted. There's less options. There's another library that's called matplotlib that is very similar to ggplot in R that has almost the exact same functionality. So I would say if you're looking for something that's exactly like ggplot but in Python, I would look toward matplotlib. Seaborn is just a little easier to use. Sweet. But it's great and all whenever you have a plot you want to make and you want to make it look nice and you want to do it quickly. However, for the purpose of data exploration, sometimes you want something a little more interactive. And that's when we use another plotting library called Plotly Express. So again, we can open the documentation here. Plotly's documentation does not look nearly as cool as Seaborn's, but again, you can go through and look at any plot that you would want to make in the documentation for it of how you would make these plots. So we're going to do the import statement again. And remember, you can run that by Control Enter, Shift Enter, or clicking the Run button. We're going to also make a box plot of that same thing in Plotly Express. So we're going to run that same run that cell and make a box plot with Plotly. So as you can see, we got the same data. It looks a little different, which is fine. However, what's cool about Plotly is you can mouse over it and get all kind of cool summary statistics and just data about your data. And so in border right here, which is one of our treatments, we see this guy at the very top up here, and we might want to go and look, investigate further at what's going on with that specific data point. So you can go through and you can make line graphs, you can make violin plots, you can make scatter plots, and all these have this kind of interactive functionality, which is really fun and really great tool for data exploration. So I encourage you guys to go through and try to make some of your own plots after this. So that's the end of the my section of this. And I think the end of the interactive portion, well, lecture portion of this workshop. So I'm going to show you guys a few different things we have for you guys, which is, if I can bring it up here, we're going to link you guys this homework, which is one of the notebooks, just like the ones we've gone through. And in here is a demonstration of each of the things we talked about today, except they've got little instructions and a little thing for you to try to complete. So here, when Chosen talked about the basic programming practices, we learned how to do basic arithmetic with Python. And so what we can do is come in here and we're going to have an instruction for each cell. So we want to print the results of adding 2 and 3. And what we're going to do is just replace that underscore with the correct thing. So for this one, if we're trying to print 2 plus 3, then we can run that. And we get 5. Sweet. So like I said, there is examples of everything we talked about today, along with just randomly interspersed underscores for you to try to fix so you can get better practice at learning how to do all these operations. As well as we'll provide a solutions notebook, which is the same notebook, except with none of the underscores and everything filled out for you. And I would really encourage you guys over the course of this coming week to take a look at that and try to work through it. And I think Emmanuel's going to have us some closing thoughts, and then I think we're going to take the rest of the time for more in-depth questions and give you guys some time to work through this notebook. And hopefully we can get it all figured out. Thank you guys again for coming.
Thank you, Travis.
Thank you, Travis. Emmanuel, before that, I just posted the homework link into the chat. Should I post the solution also?
I think we can, yeah. Travis, what are your thoughts on that?
Can you say that one more time?
Do you want me to post the solution as well as the homework itself?
Yes, please.
Okay.
All right. Can everyone see my screen? Yes, okay. All right, so I just wanted to close by reminding everyone what the upcoming sessions are. So I talked about this at the very beginning, but in closing, I'd like to refresh everyone's memory. So we just finished an introduction to Python and Jupyter notebooks. 1 week from today, so next Friday, same time, we will be reviewing shell scripts, data analysis, and machine learning. Now, just as a reminder, it's not necessary that you guys have experience with this. We will walk you guys through very similar to what we did today. For this session, we will have a little bit more interaction. We'll be showing you guys how to install something known as the Windows subsystem for Linux for people who use Windows. And for those of you who use Mac or Linux already, you guys will be ready to go. So that covers session 2. Again, that will be next Friday, same time. The following Friday, so 2 weeks from today, we will be hosting session number 3, in which we will cover version control using GitHub. So for this session, once again, we will be using either the Windows subsystem for Linux or the existing terminal on your Mac OS or Linux machines. So with that, thank you so much for coming today, and we hope that you join us for the next few sessions to build your computational toolkit.